Σας καλωσορίσω στο event που έχουμε σήμερα προγραμματισμένο και θα εξελιχθεί την επόμενη ώρα. Είναι, πιστεύουμε, μια πολύ ενδιαφέρουσα συνέντευξη με ένα στέλεχος της Lockheed Martin στον τομέα των hypersonics. Είναι ένας τομέας ο οποίος θα το ζητήσουμε βέβαια και από τον συνομιλητή μας να τον προσδιορίσει, αλλά πραγματικά το τελευταίο χρονικό διάστημα ακούγεται πολύ συχνά. Και για να βάλουμε και κάποια όρια σε αυτή τη συζήτηση, να θυμίσουμε ότι πολλές φορές η αναφορά σε hypersonics, δηλαδή σε αυτό που λέμε όχι απλά υπερηχητικό ή αυτό που λένε κάποιοι υπερυπερηχητικό, αλλά αυτό που εμείς τουλάχιστον στο περιοδικό και στα sites μας έχουμε συνηθίσει να αναφερόμαστε στο πολυηχητικό. Δεν είναι απαραίτητα αυτό που νομίζετε, αλλά θα είναι ο συνομιλητής μας, ο οποίος είναι ο κύριος Guy Chriqui, είναι στέλεχος της Lockheed Martin. Στον τομέα αυτό έχει ένα τίτλο τον οποίο κάποια στιγμή θα ζητήσουμε να μας εξηγήσει, δηλαδή είναι Hypersonics Solution Technical Domain Program Manager για την εταιρεία. Ένας μακρύς τίτλος, αλλά πιστεύουμε ότι θα έχει σημασία να μας πει. So, if we begin in English, first of all, we welcome you in our event.
Thank you.
I will ask you to introduce yourself because you have a long bio, and also maybe you can define for us your present position. By the way, I mean, that's what I was talking in Greek. What exactly is your function as a hypersonic solution technical domain program manager? It's something that a lot of people will not understand, and we wait for your explanation.
So yeah, no, thank you. Thank you for having me. Very excited to be participating in this. My name is Guy Chriqui. I'm the Hypersonic Solutions Tech Domain Program Manager at Lockheed Martin. I'll start with what that is, and then I'll talk about my biography. My job day to day is to lead hypersonics research for the Lockheed Martin Corporation. So Lockheed Martin is a giant company, 120,000 people. We have, offices all over the world, programs everywhere from undersea to in space, anything you can imagine. But within all of that, right, within all of the different companies within Lockheed Martin, there's a central function in Lockheed Martin Corporate in the Chief Technologist Office. And so I work in the Chief Technology Office as a research lead. So I direct, strategize, develop, and go out and demonstrate new novel research in the area of hypersonics for the company. That means I work across the organization. I work across a lot of boundaries in order to enable new technologies that really provide future capabilities in the future we envision, 5-10 years out from now. The equivalent to my role was actually set up by the previous CTO and vice president, or in the current vice president from our organization. They both came from DARPA, and our organization was definitely built in that model. So we are kind of equivalent to DARPA program managers, but more like we're all our own office. It's a little odd in how it works within Lockheed Martin, but we each independently generate strategies with our group of technical experts. We go out and we develop the strategies, we design new projects, and we pursue research in the hope of creating new capability. My background and how I got into that is a very long-winded approach, but I grew up in Los Angeles, California. I was a mechanical engineer in undergrad. I went to a small engineering school in the middle of the United States called Rose-Hulman Institute of Technology. I really focused on mechanical engineering, and I thought my love was robotics. I thought robots was it, and I wanted to do space robotics. I had spent time working at NASA with some of their robotics programs and a lot of the lunar robotics programs. And then I went and pursued a master's in astronautical engineering, or essentially, as I like to say, space stuff. I found out that space stuff was a lot broader than that, and I ended up, after getting my master's in astronautical engineering, going and working in the space field. helping support space operations at another company, and then I came to Lockheed Martin because I wanted to be more on the research end of things. I spent my first 5 years at Lockheed realizing that when you get into your job, sometimes you don't pursue the things you thought you were going to pursue, and I ended up developing optical instrumentation and novel optical systems for the first 5 years of my career. So if you look at my patent history, my publications, um, a lot of that is in the area of novel photonics or novel sensing. And through that, I really sharpened my skills as a program manager and understanding how the research process worked, and started to dabble in hypersonics. And all of a sudden now I'm the hypersonics guy, quite a few years later. So currently, within my role, I've been in my role for a couple of years now. I want to say four and a half as the hypersonic solutions tech domain program manager. I direct and coordinate, manage a hypersonic research budget on the order of tens of $millions a year, with impact on major threads within the company. So my position over time has grown and become more impactful, but really building off of a lot of the core skills and a general desire to learn as I go.
Okay, thank you. As we talked a lot about hypersonics, can you define for us hypersonics? Because a lot of people, even technically oriented, when you mention hypersonics, their mind goes straight to exotic weapons or things like that. But really, it's not only these.
Yeah.
So from your point of view, because you are probably the best person to answer the questions, how broad is hypersonics? What is hypersonics and how broad is your hypersonics? Mm-hmm. We really need your contribution to an answer for that.
So hypersonics is a pretty blanket term. It just means something that goes at hypersonic speed, or faster than Mach 5 times the speed of sound. As soon as you get into that regime and then you get faster than that, there's lots of funny physics that happen, and it becomes a much more challenging environment. I like to describe hypersonics as if you take everything we know as humanity, right? All of the things we've learned in chemistry, materials, physics, like all of these things, and you put them all into the same problem bucket, that is a hypersonic system. It is the hardest challenge version of all of these different sciences. So when we look at it and we look at what I'm thinking, when I refer to hypersonics, I'm not referring just to creating a really fast projectile. Think about things like enabling future travel much faster. Imagine you can go from LA to Tokyo in an hour, or and then Lockheed Martin, right? We are a giant defense company, and a lot of what we think about is defense and how we protect against some of these threats that are real and exist out there. And much of my portfolio actually looks at the holistic, integrated defense side of things. So how do you detect some of these novel hypersonic systems that are going, much faster than you would typically look for, or, they're much more unpredictable? How do you make decisions at speed? How do you engage some of these threats in a way that becomes much more viable and honestly safer? But it's a very broad domain. We have a lot of things that we think about within the domain. And that's why I like to say these are all of our problems at once, and why it's become such a challenge.
So, as you said, and as we know, because I have visited Lockheed Martin, different divisions several times, Lockheed Martin is not only a huge company, it's a global company with a lot of different pursuits in different areas. Hypersonics apply to more than one domains within the company, from space to military weapons, from research into counter hypersonics. Can you give us an idea on how broad within the company is the pursuit of and the object of your job within the company?
Yeah, I engage with, I feel like every area of the company. Within the company, we have 4 main business areas. We have Aero, which is the side that makes, these are broad generalizations. So if you're, from one of these sides of the business, it's not all encompassing, but Aero makes, fighter jets and planes. MFC makes, missiles and fire control, so they make quite a few different things like sensors and missiles. RMS makes, everything from boats to radars and also Sikorsky helicopters. And then space is all sorts of different space platforms. And, your mind can wander. We touch every one of those. We leverage everything going on. We work across all these different experts because some of our most unique solutions are coming from people who work outside of the hypersonics field, right? They're coming from novel physics or novel phenomenology areas. They're coming out of integrated systems design. How we sometimes the magic with the work we're doing is not in the individual system, but how you connect them together so you get something that's greater than the sum of its parts. We really are stretching our definitions and our boundaries, and traditionally what our defined definition roles are, because the challenge is too big and too great. We can't all just be like, I'm a chemistry guy, I don't touch anything else. No. We are a systems company. We are developing and integrating systems, and I think we're all switching to that mindset.
So if you had to pick an area or a domain that hypersonics is more advanced than others, what would be that domain or domains?
I think the ones that come to mind are materials, right?
Mm-hmm.
As these things are flying, they're heating up to incredible temperatures. They stress materials in ways that you would never imagine, and it's really just a miracle that we're able to create something that survives some of these unique environments. But also, if you go back and you think it's inside the system, you're stressing electronics, right? All of a sudden, you have to have electronics that survives hundreds of degrees Celsius. You have to have batteries that work at that temperature, wires, sensors, cameras. We have challenges in areas that wouldn't have been really present in other domains. So in many of these hypersonic systems, you either have two options. You have, in terms of what we're flying, you have ones that there's a rocket, and at the top of the rocket there's a separating front end, and there's a glide body. And then you have another one where there's an air breathing system, so there's propulsion through the entirety of the flight or through a portion of the flight. And maintaining combustion is very complicated. So there's a lot in terms of engine design and understanding the combustion physics, and the way I like to describe it is it's like trying to keep a match lit during a hurricane.
Mm-hmm.
It becomes very challenging. So we are really stressing a lot of those. Also things like modeling, simulation, understanding the physics of what's going on, because it's not well understood, or what we do understand is very difficult to model. And that's where we really dive deep in our partnerships. Is becoming a global problem, working with universities around the world, working with experts around the world, leveraging everything we can in order to provide the best solution and capability possible.
So from what I understand, all the legacy or traditional domains are extending in the hypersonic era, with different challenges and different solutions and probably different difficulties. And this is a major challenge. You mentioned a lot of times simulation. Is the simulation right now, because I understand that most of these cannot be actually tested in the real world, but the simulation is something that is the major way to overcome challenges and obstacles.
Yeah. So this is a question the CTO asks me all the time, because we go and we were at a wind tunnel tour at a university a couple weeks ago, and he was asking me, he's like, we can pretty much simulate out traditional CFD for like an airplane, like a Boeing, right? They can do everything on the computer and they know exactly what's going to happen when it flies, more or less. Hypersonics is not as well understood, and our simulation capabilities are, we work with people who are state of the art. We have people, PhDs in these areas of novel computational fluid dynamics simulation, hypersonic, CFD. There's just so much going on and so much unique physics that happens during flight. You have all these like novel emission, you have novel like chemical species separation. You have things that are happening in flight, right? Because you're flying so fast, you're ionizing the air around you into a plasma, and you're creating a really unique aerodynamic environment that is trying to be understood, and is so dynamic, right? It depends on so many different factors. Simulation becomes very challenging. We're doing a lot of work anchoring our simulation models with real world data. We have the benefit with Lockheed Martin that, the US has fielded hypersonic systems. We create, we support LRHW, we support CPS, we have our own programs. We've supported many other hypersonic flight programs. So we have access to real data. We can help support, we can inform, but we also work in partnership with our university and our internal labs within the US, like AFRL, in supporting these new challenges in many different ways, right? We're working with the universities and helping them engage on flight tests. We're trying to bring real data, real world data into the universities so they can ask better questions and help us ask better questions. We're looking to leverage the best of breed tools, working, in tools like that are really created at the university level and become commercial products like US3D. We have, experts in many of these areas, but really doing everything we can in order to understand what's going on and build on it.
So from what I understand, there is a major interaction between the industry and the academics, universities, research facilities.
Mm-hmm.
Who is leading right now the effort? Is it the industry that brings the problems and the challenges to the academic community, or the academic community is the driving force, or they are working together? Because a lot of these programs cannot involve all the academic community or the universities because of their nature and the sensitivity of the research that the industry is doing.
We're very strong partners with academia, and you'll find this is, I'm sure you're going to interview the other tech domain program managers. Part of our core ethos, right, is bringing new research in and helping transition research out of the universities into capability. We're very much in line through our office and through Lockheed Martin, engaging in these different schools and working with them. We're very collaborative in that regard. I would say there's a balance between us bringing problems to the university and professors bringing challenges to us. A lot of what we try to do at the university level is basic science, understanding what's going on. How we apply it is where the secret sauce is, and that's where it gets unique, right? But as far as understanding basic science, basic physics, going after these fundamental problems to this field, I mean, it's a win-win. We help challenge these universities. We help support research. We fund research. I fund quite a bit of research out of my portfolio. But I'm also developing my new workforce, people who can actually spell the word hypersonics when we hire them, people who've engaged in hypersonic test flights or understand what it takes in order to produce these systems. So we're always limited on experts in our field. And the more I can do to support that and create an ecosystem, whether or not they come to Lockheed Martin or not, it's to the benefit of our nation and our allies in the world to help support these people. And it always comes back in some way.
Okay. Well, regarding cooperation, I can understand the cooperation within a country like the United States, but all these research and all these hypersonic fields are right now, I guess, the edge of technology, and also they are very sensitive in the way that have to be treated. Is there international cooperation, or at this stage, each country, because there are other countries that are working by themselves, and we'll see the results in a few years, but there is no real international cooperation?
So we actually are very focused on it, and something that I am pursuing and have done quite a bit of is international partnership and collaboration. We have the benefit in the United States, I should say, where we have this massive defense industrial base that can go take these hard challenges on. But I've learned, right, I'm very engaged in the university community and very engaged in some of the academic communities. Some of the best research is not happening here, and they're happening within our partners. So there are areas where there is tremendous expertise, right? I think about something like computer science and cybersecurity out of Romania, or hypersonics in Australia is actually a really strong area. In Greece, I've seen, I've been reading papers. I think there's quite a bit of materials work. We think there's quite a bit of expertise elsewhere that we're realizing the only way we come to a holistic solution is to all come together in that pursuit. And so I'm really looking at finding ways to establish more research partnerships and understanding how we can leverage some of these basic science problems and bring them to the experts who exist everywhere. And we can always bring them in. And like I said before, the application is where things get more specific and more challenging. But I think in driving the community forward and building new technologies and engaging, right, in new industry areas, I think that's all good. And we can do all of that together.
Mhm.
Perfect.
Well,
Yanni?
yes, I'd like to ask a particular question regarding the tech behind the materials. And what I want to say is that, to my understanding, one of the most crucial factors in the hypersonic technology is actually the materials themselves. So right now, do you believe that also implementing AI and new technology regarding the materials, have we crossed the threshold of the specific technology to be spreaded widely, like, for example, the classic supersonic airplanes or whatever?
Mhm. Yeah, very, very much so. And the major thread in the work I'm doing and the push we've done for the last probably 2 years is application of AI across my domain. So I have an entire partnership with a different part of Lockheed Martin, the Lockheed Martin AI Center, where we're looking at every aspect of the hypersonic thread and figuring out how we can apply AI to enhance that area. So in the area of material application and developing new materials, for instance, right now, the materials that we typically find on our hypersonic systems is the most exotic, the most exquisite, and frankly, the most expensive. And that doesn't really work long term. And it doesn't work when you think about needing to create many or needing to create a commercial capability in some way. So applying AI to generate new materials or understand where the boundaries of materials are, that's like the perfect application. But AI is, not magic. It's always going to be wrong sometimes. So there's a balance between the way we understand our systems and the way we're applying AI that I think is unique to Lockheed Martin, where we have a much lower risk tolerance for some of these systems that have to work. So we're doing a lot of work not only in developing the AI to create these new technologies or help us in building these new materials, for instance, but also understanding that we can trust that AI and that there's validation and verification that this will not impact the mission in some other way. So it's a holistic approach to AI, but I think it's become very strong and you can let your mind wander, but we are literally applying AI across every aspect of the hypersonic system, both in, creating these systems and also defense of these systems.
So if you had to envision the near future, what would be a significant change or installation in the common life, even if we're talking about defense, for a future application of hypersonic technology?
I think some of the most unique things that we're developing in our portfolio right now are these large system integrations and making decisions quicker. The application of making decisions at speed requires a lot of new technology and capabilities. So things like, being able to detect and track something going that fast over that large of a part of the world, you have to coordinate a lot of satellites together. So you think about enabling, a bunch of satellite coordination. Maybe we're offering future internet services, something that competes with the Starlink, but is more coordinated, or we're better at predicting the weather. If you're thinking about the actual materials or the actual systems for a hypersonic vehicle, I think enabling, supersonic or low-speed hypersonic transport, we're not going to get to Top Gun Mach 10 anytime soon, but we're definitely on the cusp of enabling faster commercial air travel. And much of the technology we're developing, I think, would extend into that, or already is extending in some ways. Many of the things I talked about, like maintaining combustion during flight, those are the kinds of things that apply very easily to the non-defense world problem. But yeah, I mean, I think I always think about during the Apollo era, right? Like when NASA was creating all, we had this whole thing where we were building out, we were pursuing going to space. There's all these technologies that you wouldn't have thought about that were created. Like I think Velcro was created during that time.
Yeah.
Yeah.
Right.
Like and that's the way I look at this. We are creating new things every single day. I don't think we're going to imagine how some of these applications are going to exist in the future, but I think we're pursuing with the intent of good and the intent that we're creating new capability versus trying to destroy.
It's really mind-blowing listening to you on how wide is the domain, or how wide would be the consequences, the applications that are derived from the challenges of hypersonic in total, holistically, as you said. And although young people will be greatly disappointed that it's going to be a 10 Mach fighter in the near future, if you right now want to talk to a young person that want to approach this era as an engineer, as a person that studies computer science, what would be the advice or the guidance? There are so many applications, but what would be the specifics that a person in the university, right now in the university, would like to have a future job in hypersonics would have to pursue?
I think my best advice would be to stay curious and really be open to your field not looking the way you think it's going to look in 5 years. I think everything is moving so quickly. Everyone who's going to school to study something specific right now, by the time they get out of school, it's changed. Right? And you could think about something like computer science, where a couple of years ago it was all about big data, and now it's all about, machine learning and AI, and it's going to be or natural language processing, things like that. And you can't imagine 5 years from now what the pursuits are going to be. But I think the big thing is focus on fundamental understanding of your baseline, physics, chemistry, math, computer science, engineering, mechanical systems, materials. All of these things have application in ways that you aren't able to envision right now in some way. But building that core skill set and being able to apply from your toolbox to a new problem is the critical thing. And so maybe you might not directly impact hypersonic, or might not be like, I'm a hypersonic engineer, or I'm working on hypersonics, I'm not an aerodynamicist. But let's say you're an electrical engineer and you get really involved in high temperature electronic materials. That's just as applicable to my field as being a material science engineer for the outer shell or the coatings for a hypersonic vehicle. It's such a broad, multi-domain field that everything would apply in this area, and it's staggering when you think about it. It's a very challenging problem, and it is very broad. But I think that's what makes it so exciting, because you could throw a rock and hit anything, and it all counts.
Okay. Really a very interesting discussion. Unless if you have something else to add, we'd like to thank you for your participation, and we're looking forward in sometime in the future to give us an update on how fast things are going in hypersonics.
Very fast. I can tell you that.
Okay.
Thank you so much.
Thank you so much.
Thank you. I appreciate the opportunity.